So who can remind me about the 5 types of chemical reactions?
Formation reaction.
Yeah, perfect. So we have formation,
Hydrocarbon combustion.
hydrocarbon combustion, good.
Decomposition.
Decomposition,
Single replacement. Double replacement.
great. Single replacement, and double replacement. Okay, so make sure you guys are able to identify each of these reactions as you see them, okay? Excellent. So, we briefly talked about these steps yesterday, and they are written on the backboard by Ryan over there, okay? So, first thing we have to do is identify the type of chemical reaction, okay? Is it a formation, decomposition, single replacement, double replacement, or a hydrocarbon combustion? Okay, so that's step 1. Step 2, we're going to identify the charges on the anion and cation on the reactant side, right? Because we're predicting the products. Okay, so we need to see what the charges are. Step 3, we need to swap the anions and cations, right? On each compound on the reactant side. So on the product side, if your compound is ionic, make sure it has a net charge of 0, right? And if it is not an ionic compound, then the charge on the reactant side for that element will be the same charge on the product side, okay? So if you're ever like not sure what the charge is going to be on the product side because it is molecular, remember those always don't always have a net charge of 0, right? So if you're not sure what charge to make it on the product side, just look back on the reactant side, and whatever that charge is, it's going to be the same charge on the product side, okay? And then step 4, you're going to balance the chemical reaction, okay? So those are our 4 steps. I'll leave them up there for the next little bit. Okay, so just grab out like a sheet of paper again. If you need some, I have a lot over here, okay? Just find somewhere in your notes to complete that. 1, 2, anybody else? Yeah, you're welcome. Okay, so step 1, we're going to identify the type of chemical reaction. So what's going on here?
Formation.
It's a formation, right? Really good. Okay, so this is a formation reaction, okay? Again, we have 2 elements coming together to form a compound, okay? So iron is a metal or a non-metal? It's a metal, very good, okay? Oxygen is a non-metal, good. So our compound will be an ionic compound, good, which will have a net charge of 0, okay? So, let's look at iron. Iron is multivalent, so I should have said iron 3. Okay? Yeah, sure, we can do iron 3. Okay? So if we know that our iron is going to have a charge of +3, remember oxygen always has a charge of -2. Okay? So if I have a +3 on my iron and a -2 on the oxygen, what is a common multiple of 3 and 2? 6. Okay, very good. So how am I going to get my +3 to +6? We need 2 of them. Good. And how am I going to get my -2 to -6? We need 3 of them. Very good. Okay, so now we have +6 and -6. So we are happy, right? Net charge is 0. Cool. So this is predicting a formation reaction, okay? So again, just make sure if it is ionic, we have a net charge of 0. That's a big one, okay? Okay, example 2. What is this? A decomposition, good. Because we have one compound which is going to break apart into its elements. Okay? What am I not going to forget to do here? Excellent, okay? Diatomic, oxygen and hydrogen are both diatomic molecules. So when it dissociates, it's going to dissociate into diatomic oxygen and diatomic hydrogen. Okay? That's all good. We just have our compounds or our elements there, so we're okay. Now our last step is this balance. No? I agree. Okay, we have 2 oxygens going out and only 1 going in, right? So let's fix that right now. Okay, so now I have 1, 2 oxygens, but I have 2, 4 hydrogens, and I only have 2 going out, right? So how am I going to get my 2 to a 4? Times 2, right? Perfect. So I'll put a 2 up there. Now we have 4 hydrogens going in and out, and we also have 2 oxygens going in and out. All good? Perfect. So yeah, when you have a decomposition, make sure we're just being conscious of our diatomic and polyatomic molecules. Right? And now that we're talking about those, let's do our daily reminder for our diatomic and polyatomic molecules. Let's start with our diatomics. And we already know 2. So O2, H2, N2, F2, Cl2, Br2, I2. Cool. 1, 2, 3, 4, 5, 6, 7. Perfect. And then our 2 polyatomic P4 and S8. Very good. Neat. Okay, very good. Next one. Zinc plus hydrochloric acid. So what type of reaction is this one? What do you think? Excellent. And why did you say that, may I ask?
There's 3 components.
Okay, perfect. There's 3 elements, right? Yeah, absolutely. We have 3 elements. And if you remember our dance partner analogy, right? We have one dance partner just kind of hanging out on the side, right? And he wants his turn to dance. So he's going to swap in, right? Good. Okay, so this is a single replacement. Very good. Okay, so that was step 1, identify the reaction. Now we need to identify our anions and our cations. Let's look at hydrochloric acid, HCl. What is going to be my anion? Cl, good. Chlorine is a halogen, so it always has a charge of -1. Hydrogen will have a charge of +1. And zinc has a charge of +2, but it's just hanging out right now. Okay? So what's going to swap here?
Zinc and hydrogen.
Zinc and the hydrogen, right? Our cations are going to swap. Good. So, so zinc is going to come together with chlorine. What type of compound is this? Ionic. So I have to make sure it has a net charge of 0, right? Does it have a net charge of 0 right now? No, what do I need to fix? Perfect, we need another quorum, right? Because now we have +2 on the zinc and -2 on the chlorine, so net charge of 0. Excellent. And what's left? Hydrogen. Diatomic hydrogen, right? So H2. Okay. Good. Good. So this is where these are starting to come into play. Let's do an in and out table for this one. Okay, so I have zinc, I have hydrogen, and we have chlorine. Going in, we just have 1, 1, and 1. Going out, we have 1 zinc, 2 chlorines, and 2 hydrogens. So I just need to fix hydrogen and chlorine on the inside. So I'm going to hook a 2 up there. Happy? Yeah? Me too. Very good. Any questions so far? All good? How are you feeling with these? Getting more confident? Getting better? Yeah? Cool. 2 more to go. Alright. What type of reaction is this? Double replacement. And how did you know that?
Because there's 2 cations and 2 anions.
Awesome. Very good. So this is in fact a double replacement. And as Cardell mentioned, we have 2 cations and 2 anions. So yeah, that's a really good way to tell. Another way that you can tell that is if you just have like a bunch of compounds going on, right? It's probably a good indicator that it's going to be a double replacement. Okay, and if you have, so if you have 2 compounds that are mixing, it'll be a double replacement, whereas a single replacement was 1 compound and an element, right? Yeah, cool. Okay, so we will, now that we've identified what our chemical reaction is, we need to identify our anions and cations. So we can start with nitrate. It is a polyatomic ion. It has a charge of -1. Now, where does this little 2 belong to? The nitrate. Okay, very good. So if we have 2 -1s, and this is an ionic compound, what must be my charge on the lead? +2. Okay, very good. Iodine is a group 17 halogen, so it always has a charge of -1. And potassium is a group 1 metal, which means it always has a charge of +1, right? Okay, hopefully we can all see that now. Okay, so our anions and our cations are just going to swap. So lead and potassium will swap, and our nitrate and iodine will swap. So we're going to go lead, Pb, I'm just going to go from left to right. So lead is swapping out with the iodine, okay? So Pbi. We know lead has a charge of +2 on the reactant side, so it'll have a charge of +2 on the product side. And iodine is a halogen, so it has a charge of -1. So what? We need to have 2 of them. Excellent. Okay, and then that just leaves our potassium and our nitrate left. So we'll do KNO3. They both have a charge of +1 and -1, so that will have a net charge of 0. Good. What's our last step? Balancing. Okay, very good. We'll do our in and out chart. What is present on both sides?
Nitrate.
Nitrate. Excellent. So we will treat that as one whole thing. So we have lead, we have nitrate, we have potassium, and we have iodine. Okay, going in we have 1 lead, 2 nitrates, 1 potassium, and 1 iodine. Going out we have 1 lead, 1 nitrate, 1 potassium, and 2 iodines. Okay, so we can either start with potassium iodide or potassium nitrate. What do you guys want to do? We'll start with the nitrate. Okay, cool. So we'll put a 2 up here so that they're balanced. But I also changed my potassiums, right? Okay, so my nitrates are happy, but my potassium and my iodide on the reactant side are not. So they both have 1. I need to get them to 2. Happy? Yeah? Me too. Good. Okay, last one. What type of reaction is this? Hydrocarbon combustion, absolutely. Okay, so anytime that you see like a carbon and hydrogen and like in as a compound, that's a hydrocarbon. Okay, and when it's exposed to oxygen gas, that is the equivalent of saying that we're burning something. Okay, so this is absolutely a hydrocarbon combustion. And what are the products of a hydrocarbon combustion? Excellent. Carbon dioxide and water. Always. Okay, so it's kind of easy predicting the products of a hydrocarbon combustion, right? Because it's always carbon dioxide and water, right? Okay, let's do an in and out table. And what order are we going to be balancing this reaction in?
Carbon, hydrogen, oxygen.
Excellent. Okay, so that's the CHO chart. So carbon's first, hydrogen second, and then oxygen's for last. Remember, if you're starting with oxygen, you're going to have a bad time, right? Okay, so going in, we have 6 carbons, we have 12 hydrogens, and we have 6 oxygens plus those 2, so it'll be 8. And going out, we have 1 carbon, 2 hydrogens, and 3 oxygens. Okay? When you're setting up your in and out tables for this, if it's a hydrocarbon combustion, you're always going to have 1 carbon, 1 hydrogen, and 1 oxygen, and 3 oxygen going out when you initially set it up. Okay, it always goes 1, 2, 3. So I don't know if you've noticed that as a pattern, but that is a thing. Okay? So we will do our carbons first. So I have 6 in, which means I need 6 out. So I'll fix our carbons, but I've also changed my oxygens. So I have 6 times 2 is 12, plus 1, now we have 13 oxygens. Okay, now I need to fix the hydrogens. I have 12 going in, and I have 2 going out, so I need to get that 2 to a 12. So I'm going to put a 6 up there. Now I have 6 times 2 is 12 oxygens, plus 6 more. So that is 18. Now I need to ask myself, how am I going to get that 8 to an 18? Right, so we need 10 more. And we already have 1, so this is going to be a 6. So 6 times 2 is 12, plus those 6 there is 18. All good? Excellent. All right, so that is predicting reactions.